Hey everyone, I'm so excited today to give a full introduction to Xamarin for Visual Studio and how you can create purely native iOS, Android, and Windows applications all in C# and Visual Studio and share logic between all of the applications and still creating beautiful native apps. Now this of course is brought to you by Xamarin University, which is a place to go for the most comprehensive and up-to-date Xamarin focused training. Xamarin University offers live classes with expert instructors, one-to-one office hours to work individually with an instructor on your specific goals, an amazing Xamarin community with a private forum just for Xamarin University students and instructors, and of course the opportunity to become a Xamarin certified mobile developer, which is quickly becoming a benchmark in certification. If you'd like to learn more or enroll in Xamarin University, please go to university.xamarin.com. Now today, what we're going to do is take a look at everything that Xamarin for Visual Studio has to offer. We're going to take a look at how to get it installed, what you need to know, and actually how to start deploying and building applications. I'm going to show you exactly the different steps of sharing code across the different platforms. We're going to take a look at the developer experience and build an application out. And then of course, I'm going to show you all the resources on where to get started. Now, a little bit about me. I'm James Montemagno. I'm a principal program manager for the mobile developer tools here at Microsoft. I live in this beautiful sunshiny city of Seattle, Washington. I've been here for the last 5 years and I simply love it. I moved here to drink all of our amazing coffee and to build mobile applications. I started building mobile applications with Xamarin back in 2011, and since then I've shipped more than 70 applications across all the different app stores. I simply love it, and I just simply love talking about it and demoing it and helping developers become successful. Now, I also, besides doing webinars and speaking at conferences, I also have a podcast, which I highly recommend everyone check out. It's called Merge Conflict. It's a really great weekly development podcast on all things in development, including mobile. You can get there at mergeconflict.fm. If you're more visual and you want to see something video every single week, I also have a show on Channel 9. It's a weekly development show that comes out every single Wednesday, and you can find it on Channel 9, and there's a short URL that'll take you directly to the Xamarin show. And if anyone has any questions at all during the webinar, make sure to go ahead and fill them in and ask them. But also feel free to email me and contact me privately if you need to. motz@microsoft.com, my blog, and of course my Twitter and GitHub account is at James Montemagno. Pretty easy to find me. All right, so we want to be your complete mobile solution, giving you everything that you need. Today, we're going to be focused on the develop part and inside of Visual Studio, building iOS, Android, and Windows apps. But of course, we have the tools for testing with the Xamarin Test Cloud, build with Visual Studio Team Services, and of course, distribute and monitor with Hockey App. And all of this even comes together under the brand new Visual Studio Mobile Center, bring all together continuous integration and deployment for your mobile applications. Now, often I get asked, well, what does it mean to be a native application? Why does it matter to be a native application? Why do we need to build those? Like I said, I've been building applications with Xamarin for a long time. And what I've really realized is of how important it is to create great and really rich experiences for our users. To create beautiful native apps, we have to have these great native user interfaces and take advantage of the latest material design or design that Apple or Microsoft is doing in their applications. And there's a reason someone bought an iOS or Android device is they like the hardware, but they also like the software. So we should create software that's crafted for that device. And of course, we want to have access to every single component and widget and API that's available. So if we want to create a new iMessage application or take advantage of beacons or Bluetooth or AirPlay, we should be able to integrate those into our applications when we need to really set our app apart when we ship it on the App Store. And of course, we need great native performance. We need to finely tune and optimize our applications. To really, you click a button and boom, it just works. So you may be wondering, well, how do I get there? How do I architect these applications? And where does Xamarin fit in? Well, when I started 5 years ago, I thought I was going to have to go down this silo approach, which is writing in Objective-C or now even Swift inside of Xcode to build iOS applications. Then at the time when I started, it was only Eclipse, so I'd have to boot up Eclipse, which I never wanted to do again. But now Android Studio, a little bit better, but I have to go write some Java and build an Android app, and then I could write my Windows applications all in C# and my backends in C# and I'd be all happy. But of course, with the silo approach, you are getting native apps, but there's no shared code. You have multiple development teams and environments. And when you talk about unit testing and then you talk about UI testing, you're having all these different tools and nothing fits together. So it becomes really expensive really fast. So then you may say, well, what if I just take a bunch of code and put it in this little app generator box and then boom, apps come out? We kind of call this write once, run anywhere hybrid approach, if you will. Where often, not always, things are just kind of running in a web browser with a bunch of HTML and JavaScript. And the problem here is that you're not really crafting a great experience for each platform. You're kind of developing it's one of them and other apps kind of come along for a free ride. And since they're often in a browser, you're not getting that true performance or actually access to all the APIs. You're living in some abstraction layer, and then you actually have to go write the Objective-C in Java anyway. So you're not getting that full rich experience. I always like to say you're developing against their API, not the API of the platform. And that's where Xamarin is different. We enable you to have access to every single API in iOS, Android, and Windows, and all the other platforms that comes along with that, such as tvOS, Watch, Android Wear, and of course, all of the Windows platforms. So you get access to all the APIs and native user interfaces. But what we do is we enable you to build this beautiful shared C# backend business logic layer. So your models, view models, RESTful service calls, SQL databases, essentially things that are the same that is just C# .NET code. We brought .NET along for iOS and Android. And all that .NET logic can be shared across all these different platforms, still creating 100% native applications. Now we have two ways of building the user interface. And today I'm actually going to walk through just the traditional UI approach. I recommend also checking out the other webinar that we'll be doing on Xamarin.Forms, which I'll cover in a second. But what I fell in love with 5 years ago when I started in 2011 was really this ability to build this shared C# backend logic layer and then build native user interfaces for each platform. So I'm building iOS storyboard files, Android XML files, and Windows XAML files. So I have access to every single UI widget, but I have this shared C# logic backend, which is often 50, 60, 70, 80% of my code, depending on the application I'm building. And this gives you some real advantages, is that you get access to every single UI widget, every single material design support widget, every single crazy thing that comes out on all these different platforms. It is coding against the actual platform. So just as if you were doing it in Objective-C or Swift or in Java, you have access to every single thing that those developers have, but all in C#. So you never write Objective-C or Swift or never have to write Java. You do all of it in C#. And then we also have Xamarin.Forms approach to the user interface. And this is a shared user interface across iOS, Android, and Windows. And what we did is we said, well, not every single application needs all those widgets and all the fanciness of every little thing. But what we can do is create an abstraction of common UI controls across those different platforms. And then you can still use that shared C# business logic layer. And this is really great because you get access to things like buttons and pickers and list views and labels and entries and all these different things all in XAML, which is really nice. So you get access to all of that. Now, with Xamarin, it's of course more than just applications. We also have plenty of game frameworks and engines out there to use. Things like Urho Sharp or Monogame or Coco Sharp or the Wave engine are all built on top of the Xamarin platform to enable you to not only build applications, but of course games as well. I always like to mention that just in case you're looking to do some game development in the future. Now, the best part here is that the Xamarin platform is included completely inside of Visual Studio, including the Community Edition. So if you qualify for Visual Studio Community Edition, you already have Xamarin. There's nothing else to pay. If you already have Visual Studio, you already have Xamarin. Everything is there. And of course, everything is open source. So our iOS, Android, Xamarin.Forms are all open source, and you can read and contribute at open.xamarin.com. Read all about our open source initiatives. Now, before I get into code, I want to give you a brief overview of exactly how Xamarin works. So when I get through the IDE, you kind of have an idea as we're writing code exactly how it works. Well, I've been a Windows developer for, oh my goodness, over a decade now. At this point, building applications, for WinForms, WPF, I mean, you name it, ASP.NET, I've done it. I've done it all. And in that world, in the world of Windows, there's always been this .NET runtime, this .NET framework that I had access to that gave me access to almost everything that I wanted to do. So things like system.link and XML and numerics and IO had access to all these amazing things. And And when I wanted to go to a specific platform, I downloaded an SDK, and boom, I got platform-specific APIs that I could play around with. Think of it exactly the same with iOS and Android when you're using Xamarin. You get all that .NET goodness on the bottom that we brought over running on the Mono runtime, which is a super optimized .NET runtime for iOS and Android. So you get access to all that .NET goodness, but we create these C# bindings around every single API in iOS and Android. So there's only a few examples here, but there's thousands of APIs in iOS. So iBeacon, UIKit, Core Graphics, Core Motion, you get access to all of them. And of course, exactly the same in Android, all of that .NET goodness on the bottom, and then Android-specific APIs, including everything in Google Play Services and the Android support libraries. I mean, everything is available to you. And these C# bindings are really powerful. We actually improve the API. So we add C# features like async await, lambdas, events, delegates, things that you know and love as a C# developer. So even though I'm accessing the NFC features on Android, I'm doing it all in C# with C# features. So it feels right at home to me. Now, we do give you purely native performance across all these different platforms. On iOS, we do a full ahead of time compilation and AOT compilation. We take your C#, compile it down into IL, an intermediate language, and one more time down into LLVM bytecode, which is a compiler and optimizer to get it sent to that creates a native ARM binary that is then uploaded to the App Store or distributed internally in your organization. On Android, we can leverage just-in-time compilation and run our Mono runtime side by side the Android runtime, the Dalvik or Art runtime, because Android applications are kind of like mini VMs when they run your application. But to your users, there's absolutely nothing else to install, nothing else to have to worry about. They go to the App Store, they click download, and boom, the application is off and running, and it's great. So you get all that C#, all that .NET goodness combined with all the APIs in iOS and Android. So truly anything that you could do in Objective-C, Swift, or Java, you can do it in C# with Xamarin. Every single thing, including all the other platforms like I've been mentioning. So tvOS, watchOS, Android Wear, any of them, you have access to all the APIs. So let's take a look really quick. I want to jump over into Visual Studio. Since we went through some slides and kind of some high level things, I want to get in and start building an application. So I'm over here on Xamarin.com. So in case you haven't gotten started yet, what I want to show you is just kind of when you're walking through the page, down here you'll see Download Xamarin. When you click the Download Xamarin button, it'll give you this little quick thing to fill in and ask you if you already have Visual Studio installed. So if you don't have Visual Studio installed, it'll go ahead and install Visual Studio for you, including Xamarin. Else, if you already do have Visual Studio installed, the Xamarin for Visual Studio extension will just be installed and plug right into Visual Studio. Now, if you're over on Mac OS, it will actually just tell you and automatically download all of the Xamarin goodness that you need for the Mac there, or for some reason, if it doesn't detect it, just click on that button and you'll be good to go. Now, when you install Xamarin for Visual Studio, it's actually going to install a bunch of different things for you. So if I open up Visual Studio here, let me go ahead and zoom in here. So when I do File, New Project, what we're going to see under Visual C# is I have things like Android, so all my different Android projects, so Blank App, Android Wear, OpenGL, Single View App. These bindings projects are really cool. You can actually take a Java jar or AAR file and create your own C# bindings around it. Under iOS here, we have things such as the binding, the class libraries. Here's iPad, Apple Watch applications, iPhone applications, extensions, which are really powerful, enabling you to do things like audio units and call directory and iMessage extensions and photo editing extensions. There's like so many things in iOS. It's amazing. And then down here, we even have tvOS. So here's the tvOS and tvOS extensions that are there. And if you're more into F#, you can actually go into the F# templates, and we have F# templates to create iOS and Android applications too. I'm a C# guy, so I'm going to stick in the C# world here. Now, additionally, when you go under cross-platform, you're going to find a few different templates that are there based on what version of Xamarin you have installed today. You may have installed it previous to some of the newer updates that are there. Under cross-platform, you're either going to see a series of about 5 or 6 different cross-platform templates, or this cross-platform app right here. And what this will do is kind of like wizard of if you want to create a Xamarin.Forms project or a traditional project, and if you want to use shared projects versus portable class libraries, which I'll talk about in a bit. So I've created just a blank kind of cross-platform application. I want to kind of walk through writing some code, the structure of the application there. So what I did is I created this little application called stock demo. And the idea that I had is I have a very simple web request that I can send. So I have an Azure function set up that whenever I simply go off and send a ticker quote, so like MSFT, or if I send in like Goog in here, it will go off, trigger the Azure function, and then report it back to me. So I'll give it a second to spin up here. And there we go. We can see what the current stock quote is, and then I get a little bit of JSON returned to me. Again, if I change this back to MSFT, for instance, then I get Microsoft back. So if I go down and I look at Visual Studio again, when I create that blank cross-platform application, Visual Studio gives me everything I need to get started. So right here, I have this stock demo, which is just a portable class library, which is like a class library, but can be used on multiple platforms. So if I go to properties here, we can see that this portable class library can target .NET 4.5, Windows 8, 8.1, UWP, ASP.NET, Android, iOS, and Xamarin Mac. So all these different ones here. And you can go ahead and change these settings if you want. So that's going to give me the ability to share with the different iOS, Android, and Windows applications a single library, which is really nice. So all of my shared logic will be here. So what I did here is I first created a model for that JSON that was coming back. So if I actually come down into my browser again, I can actually highlight this here. And how I created this is I went into Visual Studio and I did edit, paste special, JSON as classes, and it'll automatically create the JSON from JSON to the class for you. So I took this and then I just renamed it to quote data. So what I want to do is I want to have a little bit of a UI that will essentially allow me to enter a stock ticker quote. And then I can go ahead get, it'll hit that RESTful endpoint, and then I can visualize the data in iOS, Android, and Windows. So let's go over here. And I personally just structure these in model, view model structure. I'm kind of an MVVM, model, view model. Essentially, my views will be the iOS, Android, or Windows 10 specific user interface. So essentially here, the models and view models are going to be shared. So the model is just pure data, whatever my data is. It could be coming from a database. It could be coming from this RESTful endpoint. It doesn't really matter. It's just some data that I want. Now the view model here, what I created was a little bit of back-end logic that will go out and enable me to query and deserialize that information. So the first thing that I had to do here is if you right click and I say manage NuGet packages, we can see that I actually have JSON.NET, so newtonsoft.json installed. So what I did is just install JSON.NET into all my different projects. And immediately I was able to essentially do high performance JSON serialization and deserialization. So just so you know, that's where that came from. So I'm only in my shared logic right now, nothing else really special here. So inside of the stock view model, what I have, I like to zoom in a lot just so you haven't seen it all. So I have this stock view model, and essentially this view model will be the code behind for each of my pages. And again, this is going to be shared. So I have a little bit of a public quote data that I can get. I have is busy flag, so is it busy, true or false? And then here I have a method that's an asynchronous method that will return true or false to me if I can get the quote. And here, all I do is I simply pass in the URL. So here's my URL that I have. I'm using a little bit of C#6 string interpolation. So I pass in here the ticker and I just go ahead and enter it right there. I go ahead and create a new HTTP client, which is included in the portable class library profile. I go out and I get that string asynchronously from right there. And then I just need to use JSON.NET to deserialize that object. So I'm taking that JSON string and I'm turning it into a C# object. And if something goes wrong and an exception is thrown, then I just go ahead and return null. Else I return false, and I set is busy to false here. Else I return true. So just a really simple, just kind of showing you that I'm going to be able to share my logic If I change any of this logic here or any of my model, I only have to update it in one place and it automatically comes into my iOS, Android, and Windows applications. All right, so let me jump back here into the project and walk around Visual Studio just a little bit for you. So we looked at the new project templates. We looked a little bit here that we have our portable class library and that shared code. Now we'll notice that we have an Android, iOS, and a Windows 10 application. I could add additional applications like a tvOS application, an iPad specific application, an Android TV application. I could add all these additional projects in here, and we'll see there's a little bit icons on here letting me know which of these are. And of course I have a Windows 10 application which could run on phone or desktop, wherever I want to be. Now, let's walk through Android first and talk about deployment and talk about getting our emulators up and running. So Android here is what we're going to walk through first. And it looks like a normal just kind of C# project, because it is. If I go under properties, I have this assembly info, which is kind of describing all my assembly information that'll be generated for me. Under assets is kind of where on Android I would store specific fonts or any like hard-coded data that I wanted to have in there in a text file that I could read. And the core of the Android application is under these resources. So Android applications have icons and these drawables, which are specifying the different resolutions. There's layouts, which we're actually going to open up, which is going to handle all of our specific Android XML, which is how Android applications lay out their user interfaces. Then we have some other things such as values, so your strings and integers, and you can do string translations in the strings.xml file. Now I want to make sure we remember that we have our references that are here. So our references give us access not only to .NET, to our NuGet packages that we brought in, but most specifically and most importantly, we have things like stock demo, which is this portable class library. So immediately bringing in all of that shared code that's there. Now I can go ahead and add a reference at any time. So let me go and pull this up. We can see that I'm referencing the actual project there. I could go through the assemblies, and if I scroll down to the bottom, we could see all the different .NET assemblies that were in here, such as numerics, numeric vectors, reflection, security, transactions, windows, XML link, all these different ones that are available to me, part of the mono runtime. Now I've gone ahead and just added like system.http and of course the stock demo that's here. And now what we can do is create our user interface and then actually, of course, bring it in and create some logic to query our shared code. So here I am. I'm going to go ahead and open up my toolbox. There we go. And we can actually look at the toolbox over here to the left, and we'll see every single actual Android widget that is available to us is right here. That's there. We also have properties. So if I go ahead and pin my properties down, I've created my user interface here ahead of time. And if I actually look at the source here, there's designer and source view, we can see that we have just a little bit of Android XML. So we have an edit text field, which is our edit text ticker. We have a button called get quote. We actually have two text views that we can update. So I can actually come in here and say Android text equals quote here. I can actually go ahead and copy this and you get some rich IntelliSense there. We'll say company here. Now if I switch back over to our designer view, what we're going to see is the designer will reload and actually get the updated views that I'm getting here. I can click around and just click on any of these. I could drag and drop a progress bar inside of here if I wanted to. I could do any of these different things. Now I'm going to select the linear layout, and what we're going to see is that over here we're going to get every single Android property that's inside of here that's available. I could add some additional padding such as 8dp, and we'll get a little bit more spacing there, for instance. So you can mess around. You can edit the Android XML, or you can edit the actual designer and get access to all of those different views that are there. So we have the edit text here, and we could put a hint in here that says enter ticker, for instance, and it'll enter ticker. So it updates in real time. Of course, you have things like switching landscape, portrait, themes. You can switch the version of Android that you're previewing currently, different themes or devices that you want. You can really kind of mess around with it. Now, this Android XML has some code behind for it. And if I go back over to my Android project, again, I like to focus on one at a time. So I have access to that shared code. We have this main layout. And every single page in Android has an activity behind it. So an activity is kind of like a page of an application. So we can see here the default template created main activity.cs for me. And this essentially is the code behind for my application. Let me bump up the fonts a little bit. That's a little bit too big. There we go. The actual logic for the code behind of it. So what we can see here is we have this attribute up top, this activity, and that's the name of it, and it's the main launcher, so it's the first thing that'll be viewed. And then we have our stock view model. Now remember right here, we actually are using immediately our shared code. So the idea here is that we don't have a lot of logic in our code behind of this activity, just very minimal interacting with the user interface, because all that the hard business logic will be done in the code behind. So let's go ahead and actually see this here. The first thing we'll see is we set the content view, and we have resource.layout.main. We create our view model so we can immediately call into our shared code. And let's go ahead and just get our fields from Android. So I'm going to go ahead and get our ticker here first, and I'm going to say find view by ID. I'll even zoom in here for us here. I'm going to say, well, first I need to find the edit text, and that will be resource.id.edit text ticker. There we go. I'm going to find my button, which will be find view by ID. This will be a button here, and it'll be resource.id.button get quote. There we go. And then I'm just going to go ahead and get my two labels. So label quote, and that'll be find view by ID, and it's going to be a text view. So specifically the Android specific namespace of what that widget is. This will be resource.id.text. And you can see our IntelliSense automatically picks up what I named it in the Android XML. And lastly, I'll do label company here. So there's a little bit of logic here to parse out the actual elements. And again, this is a text view, and we'll do resource.id.text company. So now I have access to those actual widgets. So this is an Android widget.text that's coming in. If we actually go up to our top, that's over to the top of our application, we can see that I have using Android.app, using Android.views, using Android.widget. I can come in and mess around with all of the different Android specific namespaces that are here. So Bluetooth, content, database, all the different ones that are available right there. So now essentially I can just go ahead and start adding events. So I'll just say button dot click, add a little click handler. I'm just going to go ahead and add an async sender args here. There we go. So I'm going to create a click logic handler here. And this is actually the improvement here of the actual Android API. So you'd have to do usually this override, and you'd have to handle this click thing. It's really verbose code. So we just say this is an event in C# whenever you hit click or long press or something like that in it, you have access to it. So now what I can do is I can say button dot enabled, right? And I can disable that button so we don't mess around with it again. And I'll say true when it's all done. Now what I can do is I can call into that view model. I can say var result equals await. I'll say view model dot get quote right there. And I'll pass it the ticker. So I'll get the ticker dot text. There we go. And now I can say if the result, if I know that there's a result, I can go ahead and fill in the results. Else I can go ahead and say, label dot quote or dot company dot text equals, string dot empty. And then I'll say label quote dot text equals string dot empty. Just kind of clear it out. And then what I can do here is I can go ahead and copy and paste these. But now I have this result. So I can go in and I can say, hey, what is the view model dot data dot company that's in there. And then here for the quote, I'll just say, view model dot data dot quote, current quote. There we go. So in just about under 10 lines of code, 12 lines of code or so, was that, about 20 lines of code or so, I'm going out and finding all my UI elements, adding a click handler here, and interacting with the user interface. So I'm not doing a whole lot of logic here, just going to handle those. I could pop up different dialog boxes if I wanted to, but I've just connected my user interface to the code behind and to my shared C# logic. So now what I need to do is actually get ready to deploy it to my actual application. So the first thing I always like to do is check my project settings here. So when you actually right click on the properties, we'll see a few different things. if you're in iOS, Android, or Windows applications, you're going to get some specific things. So here's the assembly name, the default namespace. You can see the different versions of Android I'm compiling and targeting. The Android manifest is kind of the overall arching view of my application and the version number. So I could fill this in and I can say, well, the package name should be mods.stocks, and the icon here should be the strawable icon. Any permissions that I need, and I can go ahead and mess around with these a little bit more. Now, there's a few places to find the Android tools besides just properties and making sure that you're targeting the correct versions of Android. When you go under tools here, we're going to see that there's an Android, an iOS, an archive manager, and Xamarin account. That's right here. So under Android, we have access to our Android emulator managers, SDK managers, device monitor, device logs, a way to get to our ADB or Android debug bridge command prompt, and a way to restart the ADB server if for some reason devices or emulators aren't showing up. Now, when you installed Xamarin, all of the Android SDKs and everything got installed for you. In fact, if I go ahead and see there's actually a toolbar with the same options here, if I tap on that Android SDK manager, what this will do is it'll go out and open the Android SDK manager that will have everything installed here. So we can actually see all the different versions of Android and everything that I have installed here. I highly recommend reading the documentation and understanding what all is important here. Now, for Android emulators, we can actually see in our drop-down menu that I have a whole bunch of them that Visual Studio and Xamarin Visual Studio has already figured out for me. So there's some of these x86 x86 Intel Haxum really fast emulators. There's some Hyper-V enabled emulators. Based on the version of Visual Studio that you've installed, you may already have the Hyper-V enabled emulators. If you don't have Hyper-V for some reason, we'll install for you the Google emulators. And if for some reason you don't have the Google or the Visual Studio emulators, which are based on Hyper-V, you can get them just by Googling Visual Studio emulator for Android. And you kind of walk through this emulator list of the device profiles and things like that on it that you want to get to. They're really nice, especially if you need Hyper-V. If you don't need Hyper-V, I recommend checking out the Google emulators. And we install some for you by default, and I've installed a few here. This is the Android AVD manager, so Android Virtual Device Manager, which I got to right from clicking on this button in the toolbar. And I actually have an Android emulator right here up and running. So since I have it running, I can simply say debug, right? And now what I can do is I can come in and I can start adding breakpoints into my application. I can add them into my shared code that's inside of here. So I could go in here, I can go in here, add a few breakpoints. And when I hit debug, it's actually going to compile my Android application right 100% on my PC and then start an actual deployment to this Android emulator, which is really cool. And the first time you kind of do it, it's going to compile, may install a few additional libraries for Android for the debug process. And here we go. We have our stocks that are here. And we can see enter ticker. I can see quote, the quote that's here. And I can say MSFT. I can say get quote. And we'll notice that the UI kind of is like, hey, something has just happened. It's because I hit a breakpoint. We can actually come in here and we can see the text of MSFT that was actually brought in. Here we have our watch window, output window, everything that you would expect. I can go ahead and continue. And notice that I went from my Android application into my shared code. I have the URL that's here that I've gone ahead and spun up. It's going to go and get this string asynchronously in the background so you can see our UI is here and alive again. So it's going to go off and make that request. And here I actually get that JSON back that's coming in. So current quote, our stock ticker quote that came in, our changes plus 0.23. I can go ahead and continue again. And then it'll say that the result was true. And I can actually look at the company data and everything that was brought in. So I'll continue again. And boom, there's our user interface. And now it's back, it's alive, and it's good to go. So I could go ahead and change it to Google and see what Google's doing. I can run through the same process, and I just have a few lines of code to modify the user interface, come back and forth. You can use all your different debugging logic that you want. So here I'll actually just go ahead and disable all the breakpoints for a second. We'll continue on, and then boom, there's our user interface yet again. So what we've done here in just a few minutes is gone out, took a look at our backend logic, that we had, which is our models and view models, tied them in, built a little bit of user interface for Android, and then tied in that backend logic. Now, what's really great here is that we've taken a look at the Android emulators, the SDKs and where to get them, how to get up and running, and how to tie in that shared logic, which is so important. But we can do that same exact step over here for iOS. So for instance, here I have an actual iOS project. The iOS project is structured very similarly to my Android project. I have my references, such as JSON.NET, the NuGet that came in, the stock demo. Then instead of the Xamarin.Android, we have Xamarin.iOS, which has all of our iOS-specific namespaces that are there. And that's really nice, so I have access to all that. Now, iOS applications are structured a little bit differently. Now, to do iOS development and to kind of get it up and running, you're actually going to need to ensure that you're able to connect and talk to a Mac machine. Now, I'm here just on my Surface Book, and I'll show you how to get through that process. So what I've done is on my MacBook that I have over here, it could be any Mac, it could be a Mac Mini, it could be a MacBook, it could be some Mac that's hosted, like Mac in Cloud or Mac Stadium, which are third-party providers of being able to rent out Macs. We can see when I go into Tools, iOS, we have a way to connect to our Xamarin Mac agent or to get to our device logs and a few other things. So under the Xamarin Mac agent, I'll go ahead and tap on this, and this will walk you through connecting to your Mac for the very first time. It says, hey, go over to your Mac and make sure that you have Xamarin installed. So you actually install Xamarin, install all the tools that you need. You go into sharing, you enable remote login. So essentially we make a remote connection via SSH, a secure connection. And then here you just say, only for me is all I want to connect to. Perfect. So now I go ahead and hit next. And automatically, the Xamarin Mac agent connection here will automatically attempt to find any Macs on my local network being via Bonjour. So all it needs is an IP address. If for some reason your Mac doesn't show up in here, just go ahead and find the IP address and you can hit add Mac and manually enter the Mac name or IP address. Now I can go ahead and double tap on this actual Mac that's here. And I've just gone ahead and set it up as if it was brand new. So I can go and just enter the username. Now this is the username of the Mac machine, not of my PC. This is the username and password of my Mac, which is so important. And if you enter it wrong, it'll tell you. I'm just going to enter my username and password, and we can go ahead and log in. Now, what this will do is it'll make sure it'll have the connection to the Mac. And the reason you need a Mac is because it's an Apple restriction around licensings and EULAs and things like that of where you can actually build and modify iOS applications. So as long as I'm connected to my Mac, I'm able to actually view the designer, deploy to simulators or emulators that I may need or to physical devices, and then actually package those applications up. Now, you only have to ever actually make this connection once, and the next time you open Visual Studio, it'll automatically connect up and be running. Now, over here, we're going to see in our toolbar, we have a few other things opening up, such as, now we're green here. The different stages of connection will update the actual icon that's here. I could get to the device logs or show the simulator if I need to. Now, what I can do is I can actually switch over to and say iOS, set a startup project because we want to deploy on iOS. Now, there's a few important things to kind of walk through. Inside of Visual Studio, you're going to see the different kind of deployment targets. Now, it may select iPhone by default if you want to go to a physical device. I like to select iPhone Simulator because that's what I'm actually going to go ahead and deploy on. And when you do that and you're connected over to your Mac, you're going to actually see all of the iPhone simulators that are up and running and ready to go and being deployed to from your PC. So let's go ahead and look at the actual iOS application. I've already written the logic here, but I'll kind of walk you through the UI. I'm going to open this thing called this main storyboard. Storyboard is very similar to an Android XML, but it's an entire overview of your application, so multiple screens. And iOS applications are kind of in this MVC, so every view has this kind of view controller back end to it. Similar to an activity. So think of on Android, you have activities, and on iOS, you have view controllers. So here's our user interface. And just like I had over on Android, I have every single toolbox, every single slider, widget, stepper available here. I can drag and drop controls onto this view. If I wanted to, I can see here's my activity indicator. I could line it up here, which is nice. You know, I can zoom in a little bit. I can say, you know what, I really want this progress little activity indicator to go here. And I want to set and make sure that it is always this far away from the left and this far away from the top, and it'll always stay on that left-hand side. So what I did is I drug over this text view, this button that's called Get Quote, and our iOS Storyboard Designer supports all the things that the Xcode Interface Builder supports. So auto constraints, auto layouts, all that stuff that's available. Additionally, you can bring out your Properties tab that's here. And when I do, we'll actually see as I start clicking around that I have names on these different properties. So here's the company, label company. I can give this one, I'll say I call this progress bar, that's there. And I'm gonna name these individual elements. So I have the different text fields and button get quote and things like that. Now, this specific view model is inside of this navigation controller, and you can drag and drop new pages around. So if I wanted to add new pages in here, I'd come up to my toolbox and I'd say, oh, okay, well, I want to add a new view controller here, and I drag and drop it down, and then I'm able to move it around on the surface as much as I want. So I'd kind of say, hey, you know, I'm here, and then I start building out this separate user interface and start building it all out. Of course, I want to zoom back in. So I've created the user interface. It's really simple here. And when I tap on this view controller, we can actually see that let me zoom in, that the class of the code behind is called view controller. So they're automatically assigned in the code behind here. So when I actually open up the view controller.cs, we're going to see something very similar to what we saw over on Android before. Instead of inheriting from an activity, we inherit from a UI view controller. We have some mixing of system namespaces, our shared code, our stock view model, our UI kit, which is iOS specific. We can see inside of here, I did something very, very similar. In our view did load, kind of our application startup, I simply create a stock view model. I create a touch up inside event, and I do something very similar here, such as enabling and disabling to get those quotes. And since I name those elements, such as button get quote, they automatically show up here for you. You don't have to do anything special. There's no find view by ID. They're directly correlated, unlike Android. So now I could say progress bar that I did in there. I can say start animating if I wanted to. And then at the end, I could say stop animating down here. So I could just add another element in there, which is really cool. Now, what I always like to do is I can just do a simple clean and rebuild in my application. And again, most of the logic here and everything here is actually just being coming from our backend logic. So we'll just simply clean. And what's interesting here is for Xamarin, I could still write and access this code even if I'm not connected to a Mac. But when I want to do that build and design and deployment to the iOS, you have to be connected to the Mac. So that's what you want to be aware of, that you'll need that green status there specifically. So now what it's doing is I've hit rebuild, and it's going to actually compile all of my C# locally. So I don't have to be connected to a Mac for that. It's going to compile. It's only when I deploy, like I said, to the simulator, will it do kind of a remote debug compilation. So here I have the iPhone 5S simulator. I'm going to hit debug. Now I'm using Visual Studio Enterprise currently. So when I do that, it's actually going to bring up our remote iOS simulator for Windows. Giving me access to a full iOS simulator control right here. So it's going to actually launch my application right onto my Windows PC. Then I'll be able to interact with it. And of course, if I have breakpoints, if I have anything I want to do, I can go ahead and add them. So here's my get quote. I can say get quote. Again, it's tying into the backend logic. We can see the spinner now spinning into our logic that's coming in here. Boom, I get the current quote that's coming back in. I can come in and see what Google's at. Boom, it comes back right away. So we're able to reuse that same business logic across the application for both iOS and Android. Now, the last thing that we're going to do here is we're going to take a look at Windows really quick. So I have a UWP application, and what do you know? It's literally exactly the same as what I had before. So here I have a UWP application. I have my stock demo. I have JSON.NET. I created a little bit of XAML. So this main page.xaml that's here, we can actually go ahead and look to see what it's not beautiful, but it's totally here. I have a simple button, and I have a text and a few text blocks that are here. And just like you would expect in the code behind here, I'm just simply calling out and updating the UI if I need to. So now if I set the iOS project as my UWP project as my startup, I can set it back to any CPU, hit deploy, and it will now use all of that shared code in my Windows 10 application. So there we go. It'll hit a deploy again, and it'll start debugging, and I'll be able to go ahead and show you what it looks like here on the desktop. So here we go. There we go. Now it's in kind of the XAML kind of viewer thing, but I'll just type in MSFT up here. I'll say get quote. It'll go out again, get the quote, and boom, now all that logic is back. So really kind of simple bringing that logic across. It's just a little bit of user interface and then bring it there. Now we saw this application obviously running on iOS here, on my Android applications. If I go back into the stock application, we can kind of see that we're still using the native UI elements, right? So you're getting material design over here on Android, kind of like the iOS look and feel over here, getting the quote, pulling in the specific UI elements that you want. Now I mentioned a little bit earlier that I have the Visual Studio emulator, the Visual Studio remote iOS simulator for Windows, and that's because I'm running Visual Studio Enterprise. And when I go into Tools, Options under iOS settings, you'll see this remote simulator for Windows. It's currently only available in Visual Studio Enterprise. Now, if you didn't have Visual Studio Enterprise, and when you set this iOS project as a startup, and you see all of your simulators here, when you hit debug, it actually start the simulator over on your Mac. So often I have my Mac and my PC side by side, for instance, or you could like do a remote desktop session or something. So just like that, we've started building shared backend logic. We built our Android, iOS, and Windows applications and sharing all that logic and building those native applications. But I'm already calling backend services. I'm deserializing JSON, but I'm doing that all once. All my business logic is shared. Now, I want to talk a little bit more about sharing code. And today in this demo, I use portable class libraries, which essentially are a cross intersection of the available APIs on each of the platforms, obviously including Xamarin, iOS, Android, and Mac as well. So it gives you one assembly to target multiple platforms. The next evolution of that, which is coming out, which is .NET Standard libraries. They're kind of available today. They're kind of going into 2.0, kind of getting ready. I still use portable class libraries today, and I'm really excited to use .NET Standard libraries because it's a single API to target basically anything that you want, which is really cool, including iOS, Android, Linux, IoT, Windows, Azure, it doesn't matter. And what's really nice is whether you're using a portable class library, .NET Standard libraries, things like that, you can consume and share NuGet packages. So there's things like JSON.NET, HTTP client, plugins for Xamarin, all these really rich things to use in your applications. Now, portable class libraries and .NET Standard libraries are a way to generate a single assembly that can be shared, but sometimes you just want to share code across iOS and Android or in Windows and not care about the different limitations, right? I don't have access to iOS or Android code in a portable or .NET Standard library. Sometimes I just want code files and I would usually link those files in. But we've created something called shared projects, which have been around for a long time now, which are kind of drop dead simple code sharing. It allows you to do conditional compilation inside of the code files. So you can say if iOS do this, if Android do this, which is really nice. Some people preferred shared projects, so they don't have to worry about writing like interfaces and abstractions to get down to the native APIs from their shared code. I will say all this really leads to really great code sharing statistics. On average, our developers shared about 70% of code across the different platforms. An application like iCircuit by my good friend Frank Kruger, I actually do the podcast Merge Conflict with, is this amazing circuit simulation application that shares anywhere between 70 here in the iOS in that kind of bluish green color, all the way up to 90% on his Windows application, which is really awesome. And the same thing with TouchDraw, which is like a Visio application, anywhere between 60 and 76% of code. And these are both traditional Xamarin applications. So that the actual gray code is any of the platform-specific APIs or the UI work that needs to be done. But all of that in that bluish green that's shared is all testable once. It's all shared across the different platforms. Now, I've walked through a lot of the development experience for Xamarin for Visual Studio, and I'll just kind of reiterate that. When you're using Xamarin, you can use Visual Studio, whether you're using 2012, 2013, 2015, 2017, any of the different versions that are out there. Xamarin will plug in and work right for you. If you're over on a Mac, we have Xamarin Studio, which is available today. That is going to give you a very similar experience to build iOS, Android, and Mac applications. It has powerful refactoring and IntelliSense built in. It's powered by Roslyn. It's a really great experience. The nice thing is that if you're using Visual Studio or Xamarin Studio, the same project, same solutions open there. So if you take this project that I just showed you and open it on a Mac, you're good to go. And of course, we also do have Visual Studio for Mac, which is in preview today, which leverages iOS, Android, and Mac development, but also adds in .NET Core and ASP.NET Core development, and including some brand new tools for Azure that's available on the Mac, which is out there. I've already talked a little bit about the iOS Designer. The iOS Designer for Visual Studio, you'll find obviously inside of Visual Studio. It's available in Xamarin Studio. It has full custom control, third-party component, live preview as you modify. The nice thing here is that it follows the same idioms from Xcode, so it's the same exact file. You could open it inside of Xcode and it will still render properly no matter what you're doing. So you can, of course, drag in custom controls, anything that you want to do. We took a look at the Android Designer, of course, available in Visual Studio and Xamarin Studio, enabling you to build all of your Android files. And again, it's the native Android-specific XML. So if you go and find some Android XML on the internet, you can grab it, pull it in, and boom, you're good to go. I did talk about the remote iOS simulator for Windows, which I simply love. It's super performant, supports all different screen rotations, multi-touch, pressure sensitive, and actually adds touch control to the iOS simulator if you're on a touchscreen PC. Of course, you can get started today just by going to Xamarin.com/download, which I showed you earlier in the webinar, to kind of run down and get everything that you need for Xamarin installed and running. I highly recommend you check out Xamarin University and the free self-guided courses. And you can register at university.xamarin.com/self-guided, or to sign up for Xamarin University at xamarin.com/university. It's completely great. When you go through the self-guided courses, you can kind of go at your pace, and all of the material that you take goes towards certification if you decide to sign up for Xamarin University later. But definitely check out the free self-guided courses. Of course, check out my show, The Xamarin Show, on Channel 9. You can get there via aka.ms/Xamarin Show. And I want to thank everyone for attending the webinar. I hope that you found it insightful and inspiring to go out and you're just building some C# business logic and then building a little bit of user interface. And just like that, you're a full mobile developer for all of these great platforms. You can find the source code of this simple stocks application on my GitHub. It's nice and simple. I'll keep the Azure Function backend up and running. So you can just download the application and go and see how I structure that application to start sharing logic across all the different platforms. And with that, I want to thank everyone.